Hello everyone, welcome back. So let's jump straight into example 2.6. Now this time we have something that is different. We have a slope triangle. Now a slope triangle doesn't give you angles, it gives you just ratios. And you might be thinking, oh well that's kind of frustrating, I really like those angles. Slope triangles are way, way better. Because all that cosine of theta does and sine of theta does is give you a ratio. A ratio for the sides that then lets you solve for them. So this just cuts out the angles, don't even have to do any trig, and you're done. Okay, so let's see how this works. Because we're going to resolve the force into its rectangular components. Now, we can use our trig functions here. Or at least we sort of do. You're wondering, like, okay, well, how do we use our trig functions? Well, we don't actually have to calculate the angle. All we have to do is remember that cosine of theta is equal to adjacent over hypotenuse. Well, what's the adjacent side for this? Well, okay, let me look at it. I'm going to say that px is the adjacent side and this is the hypotenuse, which means that it's the same ratio as this right here. So it's the same ratio as our slope triangle. So px is to 2, what square root of 5 is to 25. So I set them equal to each other. I don't have to do any trig. And then I can solve for px. So multiply both sides by 25. And I have px, which comes out to be 22.4 pounds. Makes sense, it's less than 25. That works. And I can do something very similar for py. I would use sine of theta normally, but since I don't know what the angle is, even though I can calculate it, I'll do opposite over hypotenuse. Py is opposite this little corner over here. And then I have p for my hypotenuse. That's the same thing as 1 over square root of 5. It's the same ratio. The slope triangle gives you a ratio to help you solve the problems. So I set them equal, and then I can solve for py. Now, if I wanted to, I could very well go ahead and calculate what theta is for these angles. And all I would have to do that is I'd take this guy right here. I would realize, okay, well, if I'm trying to find this angle, there's a bunch of ways I can do it. I have all the components. I would probably just use the ones I had originally, though. So the 1 and the 2, 1 and 2. And I know that opposite over adjacent is equal to tan of theta. So tan of theta is equal to 1 over 2, okay. And I can figure out that theta is equal to tan to the negative first of 1 over 2. And I would have it, I'd be done. So there are ways to go about it. I could then use theta in all of my equations, but what I would pop out is simply this ratio. It would be a number, it wouldn't be, a fraction like that, but it would pop out the exact same thing. I would have wasted a step. So the slope triangle is fantastic. Now here's a little shortcut. One of the things you use is always the hypotenuse when you're using a slope triangle. You might be like, well, do I use the 2 or the 1? Well, just look at these two triangles and look how similar they are. You see that py is pointing up and 1 is pointing up. You see that px is pointing up and px is pointing to the right and 2 is horizontal. So you use the one that matches. So py is vertical, 1 is vertical. I use 1 over square root of 5 to find py. Px is horizontal, 2 is horizontal. I use 2 over square root of 5 to find px. So use the one that matches. That's going to help you out. Okay, and that is it. We have solved. Both of these components make sense. If we wanted to, we could use Pythagorean theorem to check them. So feel free to do that. Remember, a squared plus b squared equals c squared. Don't take things at face value. Check me and see if I did it wrong. And you'll get it. So this time we learned about slope triangles. I hope it helps you in the future. And we'll move on to more example problems next time. Have a great day. Bye-bye.